In this video, I'm going to be introducing complex conjugates. Conjugates are really helpful for dividing complex numbers and then getting that division into standard form. So in this video, we're just going to introduce complex conjugates. Next video, we're going to use complex conjugates to divide complex numbers. So let's go ahead and just get started with this. So what is a complex conjugate? Well, a complex number is A, some real number, plus b, which is also a real number, times I, which is the imaginary number. Okay, so the conjugate then, we denote this by z bar, and that would be a minus bi. Okay, so you just change the sign in front of the imaginary part. Okay, let's go ahead and do an example where we need to find a conjugate. Alright, so here I've been given what z is. Z is 3 plus 4i, and I want to find z times z bar. Okay, so the conjugate, z bar, is 3 minus 4i. Okay, so now I just need to multiply these together. So I'll have 3 plus 4i times 3 minus 4i. So let's go ahead and FOIL. So I'll have 3 squared minus 4i times 3 minus 3 times 4i. And then the last, which is plus, nope, not plus, sorry, minus, right? Because I'm taking 4i times negative 4i. So that'd be minus the 4i squared. Okay, these cancel, so you're left with 3 squared minus, I'm going to bring in that square, okay, and then so I'm left with 3 squared minus, and then I squared is negative 1, so that minus turns into a plus, 4 squared. Now, so this is what? This is 9 plus 16, which is 25. But the cool thing here is that 3 and 4 we're seeing here in z. So 3 squared plus 4 squared. So I could have jumped directly from you asking me to find the conjugate, or find the z times its conjugate, to this step. Okay, so there's a theorem. I'm going to go ahead and write this here. So this is called the complex conjugate product theorem, which says that z times the z conjugate equals a squared plus b squared, right? In this case, a was 9 and b was 4. A squared plus b squared. So I can go directly from you asking me to find this product to this is your answer, 3 squared plus 4 squared. All right, let's do another example where we use this theorem. All right, so in this example, so we're trying to find the product between z and its conjugate. So we can just use the theorem, which says that this product will be a squared, which is 5, plus b squared, which b is negative 2. Oh, a squared. So that would be 25 plus 4, which is 29. Okay, you can check that this is correct. Okay, z bar is 5 plus 2i. So if you were to FOIL this out and figure out what it equals, you'll get 29. So let's go ahead and do it. 25 minus 10i plus 10i minus 4i squared. That's 25 plus 4, because I squared is negative 1, so that changes the sign. So that's 29. So you get the same answer either way, just much faster to go ahead and use the theorem.